Hello dear learners. Today in this video we are talking about practice on computation of average deviation. What is a dispersion? Value of dispersion or deviation? We have seen various measures of dispersion, right? Range is there, quartile deviation is there, standard deviation is there, and average deviation we have. That is the concern of today. Average deviation is also known as mean deviation. It is defined as the average of the absolute deviations from a central point, from a central value, that is arithmetic mean. So, the name itself is average deviation. So, it is the average of the absolute deviations from the central value, that is arithmetic mean. The other concern is that for calculating average deviation, we have to calculate arithmetic mean as well, because it is deviation from arithmetic mean. Similarly, for standard deviation also we have to calculate arithmetic mean. Just like standard deviation, initially we will calculate arithmetic mean and we will take the difference between each measure and arithmetic mean of the group. So, it is the average of the absolute deviations from arithmetic mean. Let us compute and find out the calculation how to be done. Average deviation or mean deviation is sigma of modulus x minus x bar upon n. This is the equation for raw data. For every descriptive statistics, we go for raw data and for a group data, that is frequency distribution. This is for a raw data when you are going for finding out average deviation. First you have to find out arithmetic mean, then you have to take the difference between arithmetic mean and each measure, that is x. Take the total, that is sigma of modulus x minus x bar divided by n. Average we are taking. What was the definition? Average of the absolute deviations from the central point or arithmetic mean. It's very clear, right? At the end we have given how to calculate arithmetic mean. It is mentioned, and in short what we write, it's sigma x by n, right? x1 plus x2 plus x3 plus xn divided by total of the observations. It's very clear. For a clarity, it has been written at the bottom. You got it? Let us compute it now. How to calculate it? How to calculate average deviation? Are you okay? Yes. See the formula. Remember it. How to calculate sigma of modulus x minus x bar upon n. Very clear. What are the requirements here? You will have x, first column you will have x. How will you find out the x bar? Let me write it again. Yes, x will be there. How will we find out the x bar? Yes, sigma x by n. Then you will get x bar, right? So, next column will be each x will be taken its difference from arithmetic mean, modulus. Then go for totaling of that is sigma of x minus x bar modulus. Divide it with number. You will get the average deviation. Come to this calculation. The case is raw data. Raw data, what is the raw data given? We have is 4, 6, 12, 8 and 10. This is the raw data. First I am going to calculate arithmetic mean, sigma x by n, that is arithmetic mean. What is the value? 4 plus 6, 10, 10 plus 12, 22, 22 plus 8, 30, 30 plus 10, 40. Sigma x is 40 and n is, what is n? Sigma x is 40 and what is n? 1, 2, 3, 4, 5, right? 4 is, 5 is n, right? 5 is n. Total is 40 by 5, 8. 8 is the arithmetic mean of this specific group of measures. 4, 6, 12, 8 and 10. We have 5 observations and the total value is 40. 40 by 5, we got 8 as arithmetic mean. Now the second part we have to do is to find out the difference between x and x bar. I have already told you x bar can be represented as I have already told you x bar can be represented as arithmetic mean am. Sometimes we mention it as mu as well, right? As mu. Just let me write this mu. This way also we write mu. So this is arithmetic means. It symbolizes arithmetic mean, right? So let me find out. 4. 4 is the x now. What is x bar? 8. Difference between these two, because it is, since it is modulus, we don't want to take the simple. We don't want to take whether it is negative or positive. So 8 and 4 difference is 4. 8 and 6 difference is 2. 8 and 12 difference is 4. 8 and 8 difference is 0. 10 and 8 difference is 2. Go for total x minus x bar. What it is? 4, 6, 10, 12. 12 is the total. That is total of modulus x minus x bar. Got it? The same thing we got it. Modulus x minus x bar. What it is? 12 divided by n. What is n? N is 5. 12 divided by 5. What it is? 2.4, right? 2.4. This is the average deviation of this specific group of observations. So 4, 6, 12, 8 and 10. 5 numbers are given. Initially we are going for sigma x. Sigma x I got is 40. N I have already identified. N is 5, right? N is 5. 40 by 5. Sigma x by n, right? It is 40 by 5, 8. I got it, right? 8. Now x minus x bar. Each and every observation should be taken or compared with the arithmetic mean. Take the difference. No need of taking the symbols. 4, 2, 4, 0, 2. Sigma of x minus x bar. So take the total. I got the sigma of modulus x minus x bar. It is 12 divided by total number. It is already we have 5. 12 by 5, it is 2.4. Got it? It's very simple, right? Can you do it again? Yes, I'm just giving you an example now. Do it. This is a problem for you, right? For the time being, I'm writing in this table only. 16, 12, 18, 14, 20. Calculate average deviation for the specific group of observation. This is the homework for you. You just work on that, right? What will be the value for you? First go for arithmetic mean, then go for x minus x bar modulus, then go for the total of x minus x bar modulus divided by 5. That is total number of observations. We have 5, right? Got it? Now, for a frequency distribution, what is the change in it? for a frequency distribution. Simply f has to be added before sigma. That is the only change. Average deviation is sigma of f into modulus x minus x bar divided by n. So let me rewrite it again for clarity. Yes, sigma of f into x minus x bar upon n. This is calculation of what? Yes, calculation of average deviation. See, how do we go for that? This is an equation for us. This is an equation for us to calculate it. The data set we have, this is the data set. 0 to 10 frequency is 2, 10 to 20 frequency is 7, 20 to 30 frequency is 10, 30 to 40 is 8, and 40 to 50 it is 3. Now, arithmetic mean is the first concern for any average deviation calculation. So, I have to go for arithmetic mean. For a frequency distribution, it is sigma fx by n. X is not given, only f we have. From the class, we have to find out the midpoint, that is x, right? That is x. So, x and f has to be multiplied. See, midpoint is 5, again 15, for 10 and 20, 20 and 30, midpoint is 25, 20, 30 and 40, midpoint is 35, and again 45 for the class, 40 to 50. Go for fx. I got another value fx. Fx 10, 105, 250, 280, 135. Sigma fx is 780. Total is 780. 780 divided by number, sigma fx by n. Okay, this is 780 divided by n. Let me go for counting the n. 9, 19, 27, 30, 30. Yes, 26. 26 is the average, that is arithmetic mean. Got it? So we have calculated arithmetic mean now. We have calculated arithmetic mean. Now, from the arithmetic mean, we have to find out the difference of each midpoint. That is x minus x bar or x minus mu, x minus arithmetic mean. So, x is midpoint, midpoint minus arithmetic mean is 26, minus 21, minus 11, minus 1, 9, 19. I got all these values. What is next is required? The same has to be multiplied with f. F into modulus x minus x bar. So, again the f and x minus x bar modulus will be multiplied with. So, you will be getting values like this: 47, 77, 10, 72 and 57. Go for a sigma. So, you will be getting sigma f into x minus x bar by n. It is your duty to compute now. So, simple calculation. Find out whether you are getting a very good average deviation or not, whether your distribution is having a proper deviation or not. Through average deviation, you can find out. Yes, now it is time to compute average deviation. I hope that you can do that, right? Yes. Now I am giving you one more calculation. You have to work on that. Okay? To confirm the idea that you are learning, you have to confirm it through doing it as hands-on. Do it now. Now you're watching the video, take your notebook, write the question and find out the answer. 0 to 5, 5 to 10, 10 to 15, 15 to 20, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45. This is the number students got in an examination. For example, 0 to this is a class, right? This is a class. We have grouped into a class. And what will be the frequency? So here I got 2 people very poor. 5 to 10 category, again I got 2, they are also poor. 10 to 15, number out of 50, they are also poor, I got 3. 15 to 20, I got 7. 20 to 25, average, I got 12. 25 to 30, again I got 13. 30 to 35, I got 11. 35 to 40, I got 10. And 40 to 45, I got 2. This is the 40 to 45, I got 2. This is the table I have given to work out. What do you do? See, write the formula first. Then you decide what are the terms you have to trace up. What is the formula for average deviation? Sigma of f into modulus x minus x bar divided by n. F is given as frequency here, f is given. X, these are all classes, but we need x as a midpoint. You have to calculate x as a midpoint, right? Calculate x. X is midpoint of the class. Plus 0 plus 5. 5 by 2. 2.5. 5 plus 10, 15 by 2, 7.5. That way you calculate the midpoint. Midpoint and frequency should be multiplied. The product, you will get it. That is fx. Am I correct? Correct me if I am wrong. You can use the discussion forum whenever you have any doubts, right? F into x, you will get a value that will be f into x, you will get a value that will be sigma of fx. Sigma of fx, right? When sigma of fx is given, before this is a criteria, you know, x bar is to be found out. That is sigma x by n in general, but here it is a frequency distribution sigma fx by n. Fx you are calculating, total you are getting here, and you are getting it as sigma fx by n. N is total of frequency. This is n. Either it is also called as sigma of f, right? All the terminologies we should understand. Now I got a value. For example, I got 18 as an arithmetic mean value. 18 as arithmetic mean value. Now you start doing the other part of the calculation. What is modulus x minus x bar, right? Next is f into modulus x minus x bar. This is another thing. Then you will get it here, sigma of f into modulus x minus x bar. In the equation, now we need only one thing, that is number. Number is already here. We have mentioned number. So, sigma of f into modulus x minus x bar divided by n. That is the calculation procedure of average deviation. What is average deviation? We have already mentioned it is the perfect, or we call it as absolute deviation of observations from their arithmetic mean. That is average of the absolute deviation from the arithmetic mean by each measures of the group, right? How to calculate it? We have seen n numbers of ways that we can do that. You have seen that we can do it in different way. For a raw data and for a frequency distribution, the calculations are totally different. One thing is that when you go for difference between mean and respective values, it will be very comfortable. Take it all together, that is sigma of difference between x and x bar, and divided by total number of observations. After that, we have seen computation of average deviation or mean deviation for a frequency distribution or grouped data. What is the requirement? F will be added to that. Initially, we have to see what are keywords. Initially, we have to see what are the major concern that represent a class. What are the major concern to represent a class? Generally, we use it as midpoint because class is 10 to 15, so there is no single labeling. So we mention midpoint and identify the class through midpoint. Once you get the midpoint, you will go for arithmetic mean. Midpoint into frequency, fx. Just take the total and divide it with number of observations, number of people. This is the way of calculating arithmetic mean, right? Once arithmetic mean is clear, you have to go for difference between each observation or each midpoint and their arithmetic mean. And that is also modulus. We don't want to take into account the simple. If sometimes it is negative, so you don't want to take it into account. After that, we will multiply it with frequency corresponding to the class, that is f into x minus x bar. At the end, we take sigma of f into modulus x minus x bar and divided by n, divided by total number of observations. This is the way of doing things properly for average or mean deviation. Did you get it? Do the calculations very specifically. I have given 3 tasks today. We have seen what is average deviation, how can you understand it properly and experience by calculating the average deviation. For the raw data and for the frequency distributions, we have tried different methods of calculating it. Hope you have enjoyed. Now let me ask you whether you have achieved the learning outcome. I'll be so happy if you say that, yes, I achieved. I can do now. I can do average deviation. Give me that. I'll do that. If it is no, no worries. As far as my knowledge is concerned, I have explained it in the layman's language. Once again, watch. Till you achieve mastery, watch again and again. And finally, definitely you will be with achievement as, yes, I have achieved. Have a fruitful learning. Thank you so much.